This is Mr. Elvis, and today, this video we're going to be dealing with numbers. Remember, in the previous video, we talked about the 7 branches of mathematics that we're going to be covering in this channel, and today we are dealing with the first one, which is numbers. Now, in this video, specifically, we're going to be dealing with the types of numbers, and there are 6 of them. These are the symbols. We're going to talk about them. Don't worry. So, the first one we have natural numbers. Natural numbers are also called counting numbers because that's what we use to count. 1, 2, 3, 4, 5, 6, 7 whole numbers, positive whole numbers. So let's take it out. I said natural numbers are what we call the positive whole numbers. The key word is that they are positive and they are whole numbers. So fractions are not natural numbers. If it's a fraction, it's not a natural number. It falls under a different kind of number. We'll get to that. So the key word is also positive. Any number that is negative is not a natural number. So natural numbers are positive whole numbers. They are whole numbers that are positive. Alright? So they are also called counting numbers. They are also called counting numbers. They are also called counting numbers. Now, I'll give you some examples. Counting numbers. Remember the symbol is n, don't forget that. I'll give you some examples. You already know. Some examples of natural numbers are 2, 3, 4, 5, as many as possible. 18, 24, 56, right? As far as it's a whole number, it's not a fraction, and it's not negative. So if it's a whole number and it's a positive number, then it's a natural number. Any number you use in counting, that number is a natural number, right? And the symbol is n. The second type of number is what we have as z. That's the integers. It's called the integers. That's the second type of numbers. Now, integers are very closely related to natural number. The symbol is z. Now, integers are whole numbers, but instead of just positive, they also contain negative whole numbers. So integers are positive and negative whole numbers. Positive and negative whole numbers. They must be, integers include numbers that are positive, also includes numbers that are negative, and they must be whole numbers. Again, fractions are not integers. Now, you have some integers. Let me give you some examples. Some examples of integers are basically all the numbers on the number line are integers. So you can have -4, -3, -2. These are all integers. They are negative whole numbers. You can see no fraction. -1, 0, 1, 2 continues. They have no end. 3 continues. Have no end. Right? By the way, numbers are infinite. They have no end. So negative whole numbers and positive whole numbers, including 0, are all integers. Okay? That's that. Now, number 3, the third one, let me erase this. Number 3, the third one, you have, what's that called now? Q. The number represented with the letter Q is called a rational number. Number 3, you have rational numbers. Rational numbers. Now, rational numbers, from the word ratio, it already tells you that it has to do with fraction. So rational numbers, symbol is Q, are those numbers that you can express as a fraction. Numbers that can be expressed. Numbers that can be expressed as fractions. Alright? As fractions. For example, you can have numbers like 0.5. Is a decimal, right? Yes, but it can be expressed as a fraction, 1/2, right? Just like you can also express 1.5 as 3/2. This is a decimal number, right? But it can be expressed as a fraction. So we can say that 1.5 or 3/2 is a rational number. Now, you also have 15. Okay, and let's use 25. You have 25. Now 25 is a whole number, but one funny thing is that all whole numbers, that's natural numbers, can be expressed as, that's all whole numbers, all natural numbers and integers can be expressed as rational numbers. They are subsets of rational numbers, right? That is, in this whole set of rational numbers, you have some that are integers and you have some that are natural numbers. Okay, so 25 now is a natural number because it's a positive whole number. But you can also write it as 25 over 1 as a fraction, right? You can also write it as 50 over 2 as a fraction. Okay, you can write it as 100 over 4. So, however you can write a number, any number that you can write as a fraction, that number is called a what? A rational number. Okay, I have so many more examples. Now, I should say this: all rational numbers, okay, give you what do you call it now? Non-recurring decimals. All fractions give you non-recurring decimals. We'll get to after what's it called now? After rational numbers, the next thing that we have is irrational numbers. Irrational numbers, on the other hand, gives you recurring decimals. So let me give you some examples. Number 4, we have irrational numbers. Irrational numbers. Irrational numbers. Please take note that the symbol for rational numbers is Q, not R. Right? Please don't mix that up. So we have irrational numbers Q. They're just the opposite of this. They are numbers that, let me leave you to guess that. If rational numbers are numbers that can be expressed as fractions, and irrational numbers are their opposite, what do you think irrational numbers would be? Numbers that cannot be expressed as fractions. So we have numbers that cannot be expressed as fractions or as a fraction. Alright? So we have examples. Example, we have square root of 2. If you press in your calculator, square root of 2 will give you 1.4142 ongoing. Right? Now, what do you see here? Non-recurring decimals. Right? You don't have something like let's say 10 over 3. 10 over 3 here is going to give you 3.3333. It's repeating. These are what they call recurring decimals. So recurring decimals fall under the branch of numbers called rational numbers. Because recurring decimals can often be written as what? Rational numbers, as a fraction. But when you have decimals that they are numbers, right? Their decimals are not repetitive, they are not recurring like this. They are often what? Irrational numbers. So this is an example. Alright? An example is this. You also have pi. Pi is also an irrational number. You have it as 3.142 blah blah blah. Alright? So as long as anything. So these are all, there's no how you want to write this as a decimal number. Now you might think that, but they usually give you pi in calculations as 22 over 7. The 22 over 7 for pi is just an approximate value. It doesn't give you the exact complete value for pi. So most times pi is what? An irrational number. Alright? So those are examples of irrational numbers. Now let's go further. Alright, so the fifth type of numbers that we're going to be dealing with is the real numbers. Number 5, real numbers. Okay? Now, real numbers, they have the symbol R, right? Real numbers is basically all of this together, right? The set of numbers that contains all these 4, right? So real numbers are just the opposite of this, just complex numbers. So real numbers are just the set of all natural numbers, integers, right? Let's just say, the set of all numbers, right? Including or containing natural numbers, alright, integers, rational numbers, that's Q, and what? Irrational numbers, I. So the set of numbers here, by the way, let me say this. Now these are integers, right? Take note that, let me show you like this. You have the symbol n, which is natural numbers. They are natural numbers contained, they are subsets of the set of integers. That is, they are natural numbers in integers. Because integers contain both positive and negative whole numbers, right? So the positive part of it is what gives you the natural numbers. And then some integers, or rather all integers, can be written also as what? Rational numbers. Remember, every whole number can be divided by 1. So it can be written as a fraction, basically. Now, you also have, this is also a subset. Okay, no, rational numbers are not subset of irrational numbers. But however, all these natural numbers, integers and rational numbers, as well as irrational numbers, right? Numbers that cannot be expressed as fractions. Example is 2, square root of 2 pi. So all these 4 types of numbers are all what we classify as a whole as real numbers. So the set of numbers containing all these 4 numbers, or all these 4 sets of numbers, that's what we call the real numbers. So the real number is the set of numbers that contains all these 4 numbers. Okay. Then the last type of number that we have is the complex number. Complex numbers. Now, complex numbers takes 2 numbers together. Complex numbers is the sum of real numbers, which we want to talk about here, and what? Imaginary numbers. Imaginary numbers. So the set of real numbers and imaginary numbers added together, that's what we have as what? Complex numbers. They usually have a standard form written like this. Either you write it as x plus iy, or a plus ib, or can use any letter. Okay, so let's just stick with one letter. Let's just stick with x plus iy. Right? Now, this part of the number, let me use a number so that you can understand. Let's say something like 3 plus 2i, or 3 plus i2. Okay? Now, this number is a whole number, positive whole number, and it falls under where? A real number. What kind of real number precisely? Natural numbers, positive whole numbers, right? So, now this is a real number, right? This other part that contains I or j are used to represent imaginary numbers. So do you see it? Now, this number as a whole is a complex number. Not just 3, not just 2i, but the 2 of them together, right? So this is a complex number. So a complex number is basically a real number plus an imaginary number. Hope that is understood. Right. So that is basically that. You can also have something like minus 3 plus 7i, real number, integer this time around, imaginary number. You could also have, let's say, 4 minus 24i, right? Real number, imaginary number. The imaginary number now is negative, right? So basically, it can be written with I or j, right? This concept of imaginary numbers and complex numbers is another topic on its own, but that's not for O level, that's for advanced level, that's for university level. Okay? So we're gradually going to get there. So let me just give you an example. E.g., you have 3 plus 2i, like I wrote before. Another example, you have, let's say, minus 5 plus 7i. Okay, so these are examples of what? Complex numbers. Okay? So these are the 6 branches of real numbers, 6 branches of numbers, generally speaking. Now, let me tell you something very important that you need to know. I know you might have been wondering, how about even numbers, odd numbers, prime numbers? Why didn't you say anything about that? I was going to say something about it, but I wanted you to have a broad overview first of all. So now, you may be wondering, where does all those numbers fall into? Where do real number, even numbers, odd numbers, prime numbers, where do they fall into? Guess what? They fall into the set of what? Natural numbers, because they are all positive whole numbers. So let's go. Now, numbers, or rather natural numbers, you split them into, well, let me do it this way. You have even numbers, you have odd numbers, and you have prime numbers. Okay? Now, even numbers are numbers that end with 2, 4, 6, 8, and maybe 0 sometimes. So these are all examples of numbers. So you have 10, you have 12, like that. Those are even numbers. Basically, any number that is exactly divisible by 2. When we say exactly divisible by 2, it means that 2 divides such a number without a remainder. Okay? Now, odd numbers are the opposite of even numbers. You have 1, 3, 5, 7, 9, 11, and so on. Right? 13 and so on. Right? Remember, numbers are infinite, so they have no end. So, odd numbers are basically numbers that if you divide them by 2, they have a remainder. So they are not exactly divisible by 2. Even numbers are exactly divisible by 2 because there is no remainder. Odd numbers are not exactly divisible by 2 because you have a remainder when you divide it. Now, prime numbers, on the other hand, are numbers that have 2 factors. I must say this. the characteristic, the major characteristics that make a prime number is two factors. Alright? More like it has a two-factor authentication. Now, when you say two factors, those two factors must be the number itself, and number one. Those must be the two factors that make up a prime number. For example, take a look at 3. Take a look at 2, 3, 5, 7. Now we cannot put 9 in here. Why? Because 9 has more than two factors. Prime numbers must have only two factors. Now these are the factors of 9. You have 1, you have 3, you have you have 1, 3, and you have 9. That's 3 factors, right? These 3 factors are already more than 2. And we said prime numbers must have 2 factors. So 9 is not a prime number. It is an odd number, but it is not a prime number. That is a fact. And that shows you that not all odd numbers are prime numbers, right? Right? So now 1, 3, 9 are 3 factors. That is why they are not prime numbers, because it has 3 factors. So let's go. So we have, instead of 9 now, because it's an odd number, not a prime number, we also have 11 and 13 and so on. So let's start here. Now, all these numbers, as you would see, have no other factor, no other number that can exactly divide them apart from the number itself and 1. So for example, take 5. 5 can be divided by only 1, number 1, and the number itself, 5. So these are the only two factors that can divide 5. Nothing else. So that's what makes it a prime number. It must have 2 factors, and one of those 2 factors must be 1. Alright? So that's what makes a prime number a prime number. So take note, not all odd numbers are what? Prime numbers. And not all prime numbers are odd numbers. Yes, you may think that all prime numbers are odd numbers. Not all. Because 2 is not an odd number. Mind you, 2 is the only even number that is a prime number. Or 2 is the only prime number that is also an even number. So all other numbers that are prime numbers are all odd numbers apart from 2. Take note of that. So we have done a comprehensive teaching on the types of numbers so far. We have gone through natural numbers, right, which is broken down into this. We've done also integers, which involves positive and negative whole numbers. We've done rational numbers, which are numbers that can be expressed as fractions. We've done irrational numbers, which are the opposite, numbers that cannot be expressed as fractions. We have real numbers, which is the set of all these numbers, right? All these 4 numbers. Then we also have complex number, which is the sum of real numbers and imaginary numbers, right? So in the next video, we are going to be dealing with this. Watch out for that video. We're going to be dealing with factors, multiples, and primes. We're going to be dealing with factors, multiples, and primes. Then we have prime factors, okay? We're going to be dealing with factors, multiples, and primes. So watch out for that video. I'll see you in the next video.